Wave interference. Two waves on the surface of water are generated by two independent sources vibrating at the same frequency 1.2 Hz. And here's our two independent sources. The waves travel at a speed of 0.72 meters per second. Point P is located 3 meters from source S1 and 4.2 meters from source S2. What is the wavelength of the waves? What is the extra distance traveled by the second wave before it reaches point P? What is the result of the interference at point P? And what will be the result of interference at the point P if source 2 is moved 0.9 meters further back? So it'll be moving like that. What is the wavelength of the waves? Well, we have our wave velocity equation here. Velocity is lambda times f, but we want the wavelength. So we'll divide both sides by frequency. We get lambda is v over frequency. Here's our given velocity. Here's our frequency. And we get 0.6 meters. What is the extra distance traveled by the second wave before it reaches point P? Okay, this is rather straightforward here, right? Each source creates a wavelength of wavelength 0.6 meters. The wave from S1 travels 3 meters, and the wave from S2 travels 4.2 meters. So the extra distance is just the difference between them, so 1.2 meters. What is the result of the interference at point P? Well, the extra distance traveled by the wave front coming from S2 is an integral multiple of the wavelength, right? 1.2 meter divided by the wavelength of 0.6 meter is 2. Therefore, the waves will interfere constructively when they reach point P. What will be the result of interference at point P if source 2 is moved 0.9 meters back? Well, the new distance between point 2 and point P will be 0.9 meters, that's the addition, plus the original 4.2 meters, and we get 5.1 meters. So the extra distance traveled by that second wave is 5.1 minus 3 meters here. S1 doesn't change, so it's 2.1 meters. We divide that by the wavelength of 0.6 meters, and we get 3.5. The waves will now interfere destructively at point P because the extra distance is an odd multiple of half wavelengths.